we're TeamRocket, and I'm Kelsey, Jared, Mike, Kevin, and David. This is our presentation.
Alright, the mission for this project was to create a ball shooter and a ball feeder. It had to launch 3 balls, and you could not touch the robot in between firing the balls. So it had to hold 3 balls in there at once. You can use any additional parts. You could use something about the size of a ball of water as a counterweight, and string and rubber bands.
Brainstorming before the project began, I kind of had the idea about using the motors hooked up to 2 wheels we had to hopefully have a high rate of speed. Grab the ball and fling it out quite a ways. I saw a little bit online about it. So I drew up, before we began, I had this little plan drawn up to hopefully kind of, get everyone on the same page and, start building right away. So this is pretty much the drawing. This is the first day we tried to, kind of just, jerry rig something just to see if the whole idea would work.
So we try to connect the 2 wheels with only 1 motor. So we must connect it through the gears, and the problem we have here is if we put in the amount of gears which is an even number, it will spin on the same direction, but we want it to be on the opposite direction, so we want the amount of gears to be the odd numbers. But the next problem is the size of the gear. They don't match to the distance between the 2 wheels, so we cannot figure out how to put the odd number amounts of gears in the same distance. So finally we come up with a solution to come up with a new design. And
yeah, one of the other problems we had with the wheel design, we tried for a week to make the wheel design work, ended up having to give it up just because there's too many issues with it. One of the problems we had is the motors just wouldn't spin the wheels fast enough to actually fling the ball any kind of reasonable distance, more than like 6 inches. So, but here's an example of we tried to do the gear reduction system, what that last picture was, and ended up losing all the torque. So every gear change lost a lot of torque. So by the time we got the wheels spinning really fast, we put the ball in, we just bind that up, and we even have no pressure to shoot the ball out of it at all. So that was another big issue we had besides the spacing too. So I think with those 2 big issues, it's one of the pretty much the 2 reasons we gave up the wheel design. After we gave up the wheel design, we decided just instead of trying to be over creative and trying to make something really neat, we just decided we need to do something that works. So we decided to make a catapult, tried and true. So we just basically started with big pieces, building the frame for the catapult course. This is that right there. We decided to use a call it, fling it and everything, and then we attached a ball shooter later on after we got the mechanics of the actual catapult worked out.
So when we were building the claw, we decided to use all 4 of the claws, 2 to hold the ball and the other 2 to brace the ball so it wouldn't fall out. But when we hooked up the ball feeder to it, it just ended up hitting off the bracing claws and just fall off, so we couldn't reload it. Then we decided to use 2 straight beams as the support for the ball, and that worked. Then we found out that it likes to just go fall down the arm and get in the way of everything, so we added some more stuff, and that's pretty much it with the claw. So the programming, we decided not to use any sensors to fire it. We just used a lot of timing. So the problem was it would take too long, or one of the actions wouldn't complete on the program, so the arm wouldn't fire or the ball wouldn't load. And this is the program right here. The first one is for the catapult to launch right away. Then the next block is for it to come back in for like 4 seconds. Then when there's a 1 second delay, then the C motor, which is the ball holder, the ball feeder, it goes forward, then it comes back, so it cradles the other ball.
And once again, we had problems with gears not quite meshing together, which is why we decided to go and iver it up again and rubber band the pieces so that the gears would mesh together properly and make contact.
One of the problems we had after we had actually completed the robot, for the most part, was that we still needed to build something that would put the balls on there, but we were really low on pieces. And we were trying to make something that worked, but we still wanted it to look nice. And so at the end, the solution was just building something that worked with the pieces that we had and trying not to worry so much about how it looked.
So after we finishing building the ball shooter, we start with building the ball loader, which we design as a high tower. On the top of it, there's a rail which the ball will roll on it into the floor, and there's a small pusher which will push one ball and then hold the other one, keep it on the rail, and after the ball shoot one ball, it will start pushing another one. Yeah. So the whole robot will work like we put the first ball on the floor and it will shoot the first one, and then it just push another ball and another ball from the ball loader, and it shoot the ball. Yeah, same thing.
And partway through, we realized we hadn't named our robot yet, and in honor of Jared's favorite Argyle socks, we decided to name it the Argyle bot. At first, we considered naming it something like the Ghetto bot or like the MacGyver 2 because of the rubber bands again, but we decided to go with Argyle, the common topic. And then this is a picture of our final robot and the Argyle bot.
Any question? Yep, thank you.